right, so let's make sure that we are all on the same page with what we just got from the back. Right where Margot is, you should have picked up your Chapter 5 math notes. Those are stapled. They are just on white paper. Sorry, I know I'm trying to put some more stuff on the colored paper to make it easier to find in your binder. But guys, anything Chapter 4, I would hang on to your Chapter 4 math notes, but anything else Chapter 4, you can pull out of your binder and file away in your folder in the back. That's a good idea. Go ahead if you just need to sharpen your pencil. So then you should also have 3 homework assignments, which are the ones getting collected on Friday. So if you look over at the homework board, 511, 12, and 21, those will get collected on Friday. Okay, so whether you write down the homework for the week or not yet because you don't have a plan book, like maybe we'll try to print you out like a 1-week page for a plan book or something. Yeah, I should have thought about that this morning. So today we're diving into Chapter 5.
What's the date?
The 9th. Sorry, so I do normally try to have this date right up here, so catch me if this date's wrong, but I try to have it correct up there. And because we didn't take a chance to do this, let's look at what Chapter 5 has in it. So, right up here for any of you who like to plan. So check out the board if you want to plan out the chapter here. So we've got 5 days this week, so we'll try to make it through 5 of these lessons. You can see Chapter 5 is a bit beefier, right? It's got a lot going on, so we'll probably break this up and take a quiz or a mastery, whatever you want to call it, somewhere near the end of 5.2. Probably will not include compound events. It'll probably mainly be simple, which does not mean the E word, right? Simple is just a math word, meaning not the compound version. It's simple versus compound. So that's where we're headed. We got a lot of stuff in Chapter 5. It'll take us a fair amount of the month to get through it. But today we're talking about part-to-whole relationships, dealing with food labels. Does anybody want to read? Gabe, you want to read that first paragraph about food labels there?
Sure.
And actually, go ahead and read both of them if you can.
Alright. Food labels tell you about what is in the food you eat. The nutrition facts label lists the percentages of macronutrients, protein, carbohydrates, and fat, as well as vitamins and minerals in each serving. However, it often does not tell you exactly how much of each thing is in the food, or how much you should have each day to be healthy. If you know how much vitamin C is in a serving, can you figure out how much is needed in a day? To help you answer a question like that, in this section, you will develop strategies for finding information about parts and wholes.
So let's be honest here. Who's ever been like drinking or eating something, and you turn it around and you realize there's like a little table of math on the back? Like, who's ever actually like seen this? So, flip question, who has never ever noticed there's math on your food or drinks? Never ever noticed that there's math. I'm not sure, Moss. Maybe up with Alex. We're doing the seats that we were in last Thursday, but that's the only open seat right now. So probably maybe up with... It's totally fine. Moss, just sit with Alex. You're totally good. So, guys, here's an example of a food label up top, but I thought it'd make more sense to show you some examples of like real life food labels. And this, I think, is mac and cheese. The food labels they're going to show us are real. But check this out. So real quick as we dive into this stuff, can anyone talk to me about what we see on a food label? Like, especially if you're one of those people that has looked at this before. And sorry, I'm fighting with some glare. Might be able to if I have one.
Oh, there, that's better, Mr. Hudson.
Alright, so yeah, if I don't touch anything. Yeah, June?
See the fat, the sodium. You see, like, basically all the main, like, things that people watch out for, like sodium, fat, carbs, sugar.
Yeah, the main, like, categorizations.
Yeah. And then in the, like, really tiny writing, there's all of the other, like, things included that you don't really
Like
look
all
out
the
for,
ingredients
that are
list, you
more-
mean?
Yeah, like.
So guys, anyone notice anything interesting about this food label up here? You can see it's a Diet Pepsi I just ran to the vending machine and bought, so we'd have some food labels to talk about here. don't notice anything interesting about a lot of these numbers. They're zeros. Right now, that's because this is what kind of Pepsi? Diet. So they take out a bunch of the bad stuff. Make a guess of how these percentages might compare on regular Pepsi. And yeah, Pepsi might end up flagging my YouTube video because they don't want us to talk about this probably. Make a guess of how, because those numbers probably aren't going to be zero.
There's gonna be way
I'm
less
guessing
than
the
that.
sugar will be around like 20 to 40.
250 calories. Jeez. 138%
No.
added sugar.
What?
Oh my god.
138%? What does that mean? Not trying to make you feel bad about what you're drinking, but you should be aware of what you're putting in your body. Alex is like secretively hiding their Pepsi over there. Like 138. Now guys, this is for the entire bottle, right? If I drink this whole bottle, but Gabe, what does that percent there mean?
There's more than one, like, one serving of sugar.
That's more than I should have the entire day.
That's not good.
You're supposed to have 100% in a day, and that's over what I should have in the entire day.
Should humans really even be having 100% per day?
I mean, their 100% is what would be healthy and
Okay,
a rounded
I
out
was
diet. But
wondering,
that's
is 100%
if,
as much as you can have, or is it the
well, it's what you
as
should
much as you
have.
should have?
So remember, that's a big if, though, because that's if you are consuming everything else like you should. Like, carbs are not necessarily bad. Some people, like, count carbs. But to consume all your carbs in a liquid form, probably not good because you need some actual carbs for your body to burn and, like, use for energy. Calories, not necessarily bad because calories are how we get energy. But to consume it all from a sugary soda, like, not great. So then you've got, like, other drink options, right? Now, this food label kind of makes me sad because it's not broken up in the table. But here, like, so this is Propel, right? And Propel, like, immune support. So look, since it's immune support, look at the vitamin C. 100% of your, but is that a good thing or a bad thing? That's a good thing. Vitamin C is good for you, right? It helps you stay healthy. Vitamin E is also good for you, but that only has 15%, right? Zinc, 30%. And DV, anyone know what the DV stands for? Daily value. Thank you very much, Moss. All right, so let's start talking about this in application of other foods. So let's say that we know, and really I need to pop back because I'm getting too excited. We know that mac and cheese, and you might need to write this down. I forget if I put this on your paper or not. Mac and cheese has 3 grams of saturated fat. And that is 15% of the saturated fat. Guys, there are different types of fats. Some are good, some are bad. Like I was snacking on pistachios last night. Pistachios are really fatty, but that doesn't mean they're bad, right? There's like good fats and bad fats. So saturated fat is one of the not so good fats. So if mac and cheese, now we're talking a serving, right? Careful, because like a serving versus the whole box. You eat the whole box, that's more than a serving normally.
Yeah.
One serving has 15% of your daily recommended value of saturated fat. I want you to work with your teammate. Figure out, is there a way that you can take what they just told us and figure out how much saturated fat should we have in a whole day? And nope, this one is not on your paper. Sorry, this one's not on your paper. I was trying to remember if I put this on your, so you might need graph paper to do this one.
So
How much saturated fat you should have in the entire day. So what's 100%? You're trying to figure out what is your 100%.
3 times. So you should have 12%.
I probably would.
Would it be 12%? I mean, 12 grams.
I don't know. Talk with your teammate. Process through how did you do it. If you don't know how you got there, I don't know that it would be right.
Wait.
So guys, a really good idea might be on your graph paper to give a little label that this is 511. And if you want to be technical with your label, we're talking about part to whole relationships. And what we just got told for question 5-1, because guys, this is going to give us a bunch of different information today. 3 grams was equal to what percent?
15.
15%. So I think one way we could do it is to set up a proportion. What percent are we trying to get to if we want everything? The 100%. And we want to make sure that we have labels on these things. If you're not writing, I'm guessing that you already did this. Anyone know how to go from 15 to 100? Or we might follow Ivan's advice and grab some technology. Ivan, what are you doing? You sure about that?
Yeah.
We need to go backwards.
It gives you a decimal.
So hold on, that is fine. So Ivan just said what we're going to do is 100 divided by 15 because we're looking for the multiplication. But then June said it gives you a not nice decimal. Guys, look at the screen. Trust me, real quick, I'm trying to make your life easier. Do not try to write this down. Do not try to do anything with that number. All you need to do now, it's 6.6 repeating forever. All we need to do is hit the multiplication button. Our calculator grabs that number, and we need to multiply it by 3, because that's what's going to happen in the numerator. And now that comes out to a nice number, 20 grams. So in a day, we should have 20 grams of saturated fat or less. Since that's one of those not so good things, you could go up to that or less. Lily?
I got 20 grams a different way.
What's your different way?
I set up like this chart, like 6 equals 30, 12 equals 60, and then when I got to 90, if I just add 15, that would be 105.
So hold on, I'm going to catch up with you really quick. Lily said she essentially set up a chart that was something like this. Like if I double and double, and then what'd you say you went to next? 12?
Yeah.
12 is 60%.
And then I did 15, 18, and 20.
Oh, yeah, because we can put percents together. Like, if I put these together, that would be 90%. Right? So there are other ways to get there. Guys, everyone real quick. And look in your bins. There are now protractors in your bins, but we're not using protractors. What you can use is the straight edge of it if you want a straight edge for your drawing. So pull out one of those protractors if you want a straight edge to draw on.
Of course I do.
I want you to draw a line that is 10 boxes wide. And I want you to label the left end 0% and the right end 100%. If we made this, what up, Ivan? Get up and figure it out. You know where resources are. Mark where 15% would be. Well, if we made this 10 boxes wide, what would each box be worth? 10%. So our 15% would be right here halfway between the boxes. 15% and 3 grams. So this sort of model is what we're going to start to use as we keep moving forward. But can you, like, in your brain, can you figure out how 15% goes to 100? I can't. Y'all might be smarter than me, but, like, this doesn't feel, I'm going to say it, this does not feel easy to me. right? Like even when I draw the diagram like this, the proportion up here is really what feels easier because we can just grab the calculator and do it that way, which is why we're going to come over here real quick and look at, in 511 up here, we've got some blank lines that need filled in. So check this out. A ratio, this is an example of a ratio, is a comparison of two quantities by what? How are these two quantities? Addition, multiplication, division, subtraction. What's going on? A division. A ratio sets up division or a fraction. So guys, you want to fill in on that paper. It's real easy to tell who's not doing it. A ratio, when we set it up, it looks like division or a fraction. That doesn't mean that we have to do division. You with me, Raphael? Because I don't think I've seen you write since I wrote this down. So guys, a ratio can be written with words, fraction, colon notation. So let's go ahead and use this example over here on our paper. If we want to write the ratio, I'm going to highlight this. I know my notes are a little awkward today because I was trying to fit everything in. We want the ratio of girls to total students. So if we write like girls compared to all, how many girls are in the class? And guys, every bin, I just did this morning. I saw something showed up and I was getting all OCD. Every bin has every color of highlighter. Every bin has Post-its. Every bin has calculators. You all have everything I'm using. So grab a highlighter if you want. We're setting up the ratio of girls to students. So girls to everybody. How many girls were there? 15. Thank you. How many total students were there? 28. Now hold up. 15 to 28 with the colon. Guys, I don't actually think that's all that convenient. A lot of us will not be able to use this colon to do much with. So I want you then to write like or an arrow or something. A better way to write this is 15 over 28. That's saying the same thing. And you could also write out the words 15 to 28, but I don't really want to write words. That's not this class.
That's for ELA.
Right?
I didn't say anything. I didn't say anything. Aye.
And guys, this is comparing girls to total students. These are two different labels. And this is what we've been practicing all year, but now we need to get to the point of showing we've really mastered this. So here's an example down here of a proportion. Guys, if I was you, I would write in proportion. Because these are great notes that you can refer back to. A proportion is a fraction equal to a fraction. So like A over B equal to C over D. Whatever those numbers are, like 1/2 equal to 2/4, 1/2 equal to 4/8, 1/2 equal to 10/20. Yeah, X over Y equal to 3X over 3Y. Right? We could set up any proportion. We could do this forever. But make yourself a reminder, whatever happens on bottom through multiplication is what happens on top through multiplication, and we get back to our friend, the giant one.
Yeah! I like doing math with the giant one, honestly.
So guys, even though we're going to start to use some percent diagrams like this, a proportion will always work. Questions on the part I gave you in your notes to remind you what's going on with proportions. Because now we're going to move on to this down here, but you can still use proportions, or at least proportional thinking. All right, so check these out with your teammates. Let's move on and read them. All right, so this is now, they don't tell us what food, but now this is fiber. What's fiber make you do? Fiber makes you poop. So if you can't poop, you probably aren't eating enough fiber. So 4 grams is 16%. So guys, on your paper where you have 4 grams, but you're missing 16%, I would fill in 16% right under there. It's missing on your paper. You should write it in. Notice how it says copy, but I did the copying for you. What we need to do is complete. What percent would we be missing if we already got 16%? Okay, so we all wrote 16% here. Talk with your partner. What percent are we missing, and how much fiber would that percent be? Solve it whatever way you can figure out to solve it. Go for it. With your partner. With your partner. I just realized my sleeves are uneven. I think. Can't tell. I think 16 and 4 work nice together. I feel like 16 and 4 work nice.
Yeah, they do.
I feel like 16 and 4 seem to work nice. So put a percent sign there to make sure that we realize we're talking percentages. And then how could we figure out the missing percent? Well, if we know we're trying to get to 100, and we've already taken up 16, make sure you guys are talking together. Ooh, we haven't done a nice round of random cards yet. Well, we'll shuffle them up for the new week. Jana, what percent are we missing here? 84%. We can do 100 minus the 16, 84%. Ivan, did you figure out how the 16 and the 4 work nice together? Ooh, they're divisible. Who saw that 16 and 4 are commonly divisible by, what can they both divide by? 4. So guys, we could make an equivalent fraction and say 1 gram is how many percent? 4. Every 1 gram is 4%. You guys see these, right? My friends with their hands. Or do you have questions? Because if you're trying to give answers, I'm using these. Yes, but irrelevant right now. True. And awesome insight, but not important right now. Yes, but don't confuse me. I love what you're thinking, but I don't want to confuse other people because we're not talking roots or squares right now. Nate, do you know how I could get from 4% to the 100% that I want? Yeah, absolutely. Miss? We could multiply by 25, or guys, there are other ways to do this. Right? You could also go from 16 to 84, you could go from 4 to 84, whatever number you decide to use. But if we use this, we see that our total, guys, not what's up here, but our total, our 100%, is 25 grams. What does that mean we're missing right here? Anybody? 21. Can what? Can we what? Questions. And it's okay if that didn't flow as easy as it might have for other people, because it's not. We're just learning this. This is brand new. So let's try it again. Look at the next one on your paper.
Oh, there's
I know. I got to give you the info on the next one. So 6 milligrams. Here's your info that you need. 6 milligrams of vitamin C is in 1 large carrot. not the baby carrots, love those, but a full-size carrot. You want 60 milligrams each day. So Risa wants to calculate what percentage of my vitamin C am I getting from a carrot. So chat with your neighbor. We're going to fill in everything we just got told. Yeah, so it's always 0 right at the beginning, but be careful. This question mark is asking for this little section, that little section, we can fill that in together. How much did she get from a carrot? 6. So what she's looking at right there, that's 6 milligrams. The total that she needs to eat. Ooh, 6 and 60. 6 and 60 seem a little nice. And guys, a note you might be making on your paper is if 60 milligrams is 100%, how does Risa get down to 6 milligrams? Divide by 10, right? So what percent is that going to be? 10%. So yeah, guys, we get 10% here because it's really a division by 10. Right? She split up her line into 10 parts. And if you count on your paper, you can see these are 10 parts. So each part is going to be 10%, which means, well, how much percent is left over here? 90. And that 6 milligrams was 10%. So how many milligrams are left? 54. Is this making a little bit of sense? So if all you had to eat today is a carrot, you should probably eat a whole lot more. Or 9 more carrots. Now you got all your vitamin C.
I'm chill.
Who's thinking of Bugs Bunny right now? Who's just subtly in the back of your brain, if we're talking about carrots, try this. We're going to mix paint. Yay! Alex has decided they're tired of their bedroom color. They want to make purple, but they've got blue and they've got red. And Alex is like, I can make purple. I'm in art class. I know how this works. You don't want me to just make up what you've said or done? That's not cool.
I totally did that.
So, if we need 3 parts blue, 12 parts red, that really means we're going to need how many total purple parts? Well, what's 3 and 12?
That's 15.
3 and 12 together. What do you get? What's 3 plus 12? 15. Now, wait a minute. Here's the question. What percent is blue? What percent is blue? Turn to your neighbor, see if you guys agree. What percent is blue? So blue got 3 of the parts. What percent is blue? So blue had 3 parts. Right? 3 parts. Out of how many total? Out of 15. 15 total. 3 over 15. Christian, is there anything that I can do with 3 over 15?
Pass.
Donovan, anything I can do with 3 over 15? Nah. I can multiply both of them by 5. You're right. I can use a giant one there and do that. Keegan, thoughts? 3 and 15. I don't have to just get bigger. I could get smaller first.
I think maybe Miss wants to go.
15 divided by what? And then I'm also going to do... So I agree with you, but I want to make sure we're doing this the same. If we divide by 3 on top and bottom. Guys, you could write this down. We get 1/5. Essentially, blue is 1/5. Right? Because we divided by 3. And we divided by 3. But now 1/5, if I want to turn this into a percentage, I need 100 on bottom. So like Keegan said, now we're going to multiply item times what?
Times 2.
Not just 2. There is a 2. 20. So this becomes 20. So our blue, we can come back up here and fill in. Blue is 20% of the paint. Blue, which means what's red? What percent is red?
80%.
80%. For that shade of purple. Lots of shades of purple. Questions on using our proportions. We can multiply, we can divide. Cannot add or subtract, guys. We're always multiplying, dividing. Always multiplying, dividing. Real quick before, we got a few more minutes, but real quick before we get out of here, let's all look at the math notes and make sure you're comfortable with what's in them this chapter. Look at your math notes. So notice how part of what's in your math notes was also what was in your 511. Because I want you to always be able to refer back to this. So this shows you the 3 different ways that ratios can be written, including the labels. This is why we did not write them out on our paper. The example with the raisins and the peanuts. Right, if we multiply by 20 on top and bottom. An example of showing this in tables. So if there are 3 boys to every 5 girls, if there are 6 boys, there's 10 girls. If there's 9 boys, there's 15 girls. Right? We can multiply by 2, by 3, by 4, whatever we do. So wait, what if we multiply by 4? We get how many boys and how many girls?
12 and 20.
12 and 20. So we could go ahead and down here we could fill in our 12 and 20. Because our multiply by 4... Go ahead and flip, because we'll just keep looking through everything that is in these notes. This is what we did today, right? Part to whole. Let's go ahead and finish this out, since this is what we did today. If the bottom here shows 40%, what percent are we missing?
60.
60. Let's go ahead and fill that in, guys. Now wait, if 220 boys was 40%, guys, I want to show you a really convenient trick. And I hate the word trick. I need to come up with a better word. You could either do this on your paper or grab a Post-it, but I'm going to pull over this blank piece of paper so I got something to write on. Guys, 220 boys is 40%. I want you somewhere to write down 220 over 40%. And you could just do this on your paper, but you could also grab a Post-it out of the bin, or you could do this on your graph paper. Guys, there is a method that like my classes have developed over the past couple of years that we just nicknamed the 10% rule. Because if I can find 10%, I can find pretty much anything else. So any situation we're given, we should ask, can I figure out the 10%? And we should be able to. How could I go from 40% down to 10%?
Divide by 4.
Divide by 4. Show that work.
So then you divide the top by 4.
And we do the same on top. June's over here flexing. And we get that 55 is 10%. Now, can I go to 60%? Yeah, because now that I'm at 10, it's kind of the E word. Guys, and if I want to get smaller, could I go from 10% down to 5%? Could I go from 10% down to 1%? Could I go from 10% up to 100? Yeah. Guys, if you get to 10%, you're pretty much halfway there. More than halfway there. Keegan? So what Keegan is saying is we could have done, what would 20% have been, Keegan? 110. You're absolutely right. There's no reason that we couldn't. This is just the way I wanted to show you. Because in this situation, the 40 can get to 20 nicely. But I want to encourage you guys, any situation, the 10% rule can help us. So hold up real quick before I forget to do this. If I do times 6 and... What is it? I feel like it needs to be bigger than that. Yeah, 330 sounds better. So that means there would be 330 girls, and the boys are outnumbered.
I would feel very uncomfortable there. Everywhere.
I don't know, man. A lot of times girls are kind of nicer than boys. They're more mature. Girls mature faster than boys.
It's true.
This is not throwing shade. It's science. It is science.
It is true.
All right, hold up. We got a couple. Your sister's younger than you. Moving on. If we look down here, guys, this is more examples of what we just did, right? 40%, but they do 40%. Guys, this is your 40%. 40 out of 100. Be careful. That's not comparing two different labels. That is your 40%, right? 40 out of 100. So be careful to include labels when we got them. There's just other examples. I'm running out of time. Yeah, hold on real quick. Let's look through the last couple pages because I got a couple minutes. So then, all of this was pretty much part of the whole relationships. Flip again. Then we've got independent, dependent events. Guys, this is straight up part of your homework. Like a couple homeworks from now, like not tonight, but it will ask you, are these independent or are they dependent? Right here. Like we'll talk about it in class, but if you forget, right here. Then compound, like we said, simple versus compound. Compound is where it gets more complicated. We'll learn this stuff. Don't worry about it. Then I've got a bunch of examples here. So when you start talking about probability tables or probability trees, all of these are giving you an example. And then the 5D process. But SOF, because the accelerated class is, accelerated and they're moving faster than this, SOF decided for Christmas to make me the 5D process as defined by SOF. So SOF's 5D process says, when confronted with a difficult math problem, use the 5D process, which is demand for help, deny it, delay as long as possible, doubt your ability, and ask Dad. So I don't know if that 5D is as good as this 5D, but we'll get there. But that's SOF's 5D process. And then the very back is just a little note about consecutive integers. But all right, guys, that's all we got for today. Please clip this stuff in your binder. Clip it in. I'm watching those of you that I'm scared about right now.
Sugar
Guys, flip your
timbers.
notes back to the front and clip your
Say
papers
sugar
in.
timbers.
These in. Like, we just got asked to do 5 copies. Boss, mind your business. So, this is everything from today. So we have another 5 paper. Yep. So here we go. All of this is chapter 5. So this should stay together. We should flip it in to keep it safe.
Looks great. I don't
Do we have holes? Oh, this guy's direction. And then we need to get these done, right?
Mr. Hudson.
Yo.
Coach that is like really fun though. So
Well, I think Soph is getting help from her dad, and he's trying to teach it in a more complicated way that, I haven't taught yet. So then Soph is coming in confused. She's like, wait, what is this? And I'm like, this is We haven't learned that